Hi, this is the third part of our video series about our course Statistics, and today we are going to learn some visualization techniques for our data sets. And we are going to start with the data again. And I think you remember data is any kind of information, and also the name of this course Statistics was the science of organizing, collecting, organizing, and analyzing the data, right? So a data can be variables, and also data can be cases. And what are they? We just learned about variables in the last video, and variable is a property or feature that something of something or someone. So variable can represent the characteristics of something or someone. And cases are this something or someone. Okay? Something or someone. For example, suppose that we have just some students and we have their ages, and these numbers are variables, and these students are cases. Okay, cases. So a data can be a variable or a case, and also we can present all this data, whatever it is, variable or cases. We can use some visualization techniques, and today we are going to learn these techniques, visualization techniques, and we are going to start with the easiest one. And let me change the page for you. Yeah, the easiest one is this table, and it's called data matrix. Okay, data matrix. This is a simple table, and it includes some data. And look at this table. We have some student IDs, and we have the age of these students, and also we have the eye colors of these students, we have the weights of these students, and we have 4 columns in this matrix, in this table, and one column is for case and the other 3 column is for variables. Okay, remember the last page? We have cases and variables as data, and one column in this matrix is case and the other 3 columns are for variables. And I want you to pause the video now and think about which column is the case and which columns are for the variables. Okay, just pause the video and think about it. And let me continue, and I want you to look at this number. Okay, look at this number, student IDs. For example, the first one, 170, 303, and 001. Okay, this is a number, but it isn't a numerical value, right? It's non-numerical. Why? Because the student IDs in our university is just a coding, and the first 3 digits is for your starting year to university. Starting year, for example, for this one it's 2017, and the other 3 digits are for the department that you study. And if I'm not wrong, this is for mechanical engineering, I think. And the last 3 digits is for your student number. Okay, so this number it's like our citizen number. It's not a numerical value. So each number, each combination of this coding is just for one student. So this is the case. This is the case. This is a unique value that indicates just one student. Okay, this is the case. This is the case. And the other three columns are for variables. Because they're about the properties of these students. Age is a property of a student, and also eye color is a property of a student. Weight is a property of our student. But the student ID is a unique value that identifies the student. So it's the case. And this is the simplest way to present a data set. It's called data matrix. And the second step is to create a frequency table by using this data matrix. We're going to create a frequency table. And in a frequency table, we just have three columns this time. Frequency table. And let me start with the, for example, age. For age. And we will have just three columns, and the first one is for the values, and it will include the different values. Okay, each possible value for this variable, and in this example it's the age. And the second column is for count, and the third one is for percent. It's for the percentage values. Okay, so let me change the color. And first I want to find out the possible values for the age, and I think we have 21 and at least 19, and all the values are between 19 and 22, right? 19 and 22. So we have the values starting from 19 to 22. So we have 19, 20, 21, 22, and not 23. Okay, we just have these four values. We just have these four different possible values, and we have to count now. How many 19s do we have? Okay, so 1, 2, and it will be better if I use this color. 1, 2, 3, 4, 5, 6, 7. Okay, we just have 7 students who is 19 years old. Okay, and let me count for 20. 1, 2, 3, 4. Okay, we just have 4 students who is 20 years old now. And for 21, we just have this one. 1, 2, 3, and that's all. 3, and for the last one, 1 and 2, right? Yeah. And let me take a sum of these numbers to make it. I think we have 16 students, right? And this is 14, and plus 2 is 16. It's okay. We just have all these numbers. So, and I have to calculate also the percentage values. Okay, so how can I do this? So I just use these numbers. 7 over 16 times 100, and for this one 4 over 16 times 100, and for this one 3 over 16 times 100, and for this one 2 over 16 times 100. And this is the easy one. This is 25%, and this is 12.5. and let me calculate the other values. I need a calculator. Okay, 7 over 16, and it makes 43.75%. 43.75%, and also for 3 over 16, it's 18.75%. Okay, and this is a frequency table. This is a frequency table. And also I have a question for you. Now, in this part with the data matrix, we just have all these numbers. We have the numbers for 16 students, and in a frequency table, by creating a frequency table, we just did a type of statistics, right? We just did a type of statistics, but what kind of statistics? Remember the first video, remember the first part, and we have learned about the main groups, main types of statistics in that video, and they were descriptive statistics and inferential statistics, right? So in descriptive statistics, what were we doing? We just summarize the data we have with just few numbers, right? So this process is descriptive statistics. Descriptive statistics. Why? Because we have all these numbers in our data matrix, but in a frequency table we just have these numbers. Okay, and also we lost some of our information. We have lost some of our information. Lost some information. Why? Because by looking at this data matrix, we know that, for example, these students, the number one student is 21 years old, but when we look at this frequency table, we cannot understand who is 19 years old, who is 20 years old, who is 21 years old. We can just know we have 7 students who are 19 years old now. Okay, and we have lost some of our information, but it becomes more meaningful when we look at this table. So we can understand from this table, from frequency table, we can understand the most common age is 19 in our classroom. But when we look at this data matrix, we can understand who is 19 years old, who is 21 years old, who is 20 years old. Okay, we have lost some information, but it becomes more meaningful, and it's called descriptive statistics. We just summarize our data with just a few numbers. Okay, and it's called frequency table. It's the first step for the visualization techniques. Okay, now we have this table, and as a first step we can create a bar chart, for example. But first let me write down these numbers in a smaller area to create some space for me. This is the data matrix. Let me arrange this table, data matrix, and this is the frequency table for age, and we have percent, we have numbers, and also we have the values, and we have 19. Sorry, I'm gonna use the white color. We have 19, 20, 21, and 22. We have 7, 4, 3, 2, and also 43.75%. and 25%, 18.75, and 12.5. Okay, now I can clear this area, and I'm gonna create the first plot for me. Okay, I'm gonna create the first plot, and this is called bar charts. Bar charts. And as you can understand from the name, we are gonna use bars to create a visual way for our data. And in a vertical axis, I'm gonna use the count numbers, count, and in horizontal axis, I'm gonna use the values. And also, I think I can use the lines from this program, right? It's better. It's way better. Now we have count in vertical axis, and also we have values in horizontal axis. And which values do we have? Which values do we have? We have 19. Okay, we have 19, and we have 20, we have 21, and also we have 22. And what is the maximum value? It's 7 for 19. So I can scale in vertical axis with a maximum value of 8, and in the halfway I'm gonna use 4, and this is for 6, and this is for 2. Okay, now I'm gonna draw the bars, and 7 for 19, and 7 is here, right? 7 is here, so I'm gonna draw, and also I can use these lines. I'm gonna draw a bar for 19. Okay, like this one. And also for 20 we have 4, so I'm gonna draw a bar like this one. Yeah. And also for 21 we have 3, so I'm gonna draw this bar. And also for 22 we have 2, so I'm gonna draw this bar. Okay, now it's more meaningful than a frequency table. Oh, sorry. Now it's more meaningful than a frequency table, and it becomes in a more visual way to express our data. So when we look at this chart, this bar chart, we can easily understand that the maximum value is for 19. So we have the most of our students in 19. Okay, this is the bar chart. And also we can use pie charts, and in pie charts we are going to use a circle. I'm going to use this area, pie chart. This is very easy to understand, and also this is very easy to draw. We are going to use a pie chart, so we are going to create a pie like this. Okay, and we are going to divide the area inside this pie by using just the percentage numbers. So I think this is the center, and also I'm gonna use this color, and this big slice is for 19. Okay, and this is a quarter slice is for 20, and also this is a half quarter slice for 12.5% for 22, and also this is for 21. So we have, sorry, we have 19 here, and we have 20 here, we have 21 here, and we have 22 here. Okay, this is a pie chart, so it's very easy to create, and also it's very easy to understand. We just draw a pie, and then we are gonna arrange the area inside this pie by using the percentage numbers. Okay, and also we have some special names for these numbers. Okay, in frequency tables we have this column count, and also it's called absolute frequencies, absolute frequencies, and this is percentage numbers, and these numbers are called relative frequencies. Okay, these are the two types of frequencies, and these numbers are for absolute frequencies, and the percentage numbers are for relative frequencies. And we learned about bar charts and pie charts, and also I have a different version from a bar chart, and it's called histogram. And in a histogram we just use the percentage numbers, but this time we can use some classes, some margins other than the values. Okay, if we have a lot of data, if we have a lot of numbers in our data matrix, so we cannot use the values one by one. So if we want to produce a meaningful chart, then we just define the margins between our values. And I'm gonna clear the page, and I'm gonna draw an histogram. Okay, suppose that I'm gonna start with the frequency table. Suppose that we have a data set, and also I won't use these data matrix, so okay, I can clear. Now suppose that we have a frequency table for ages. No, this subtitle is very wrong. I'm not gonna kill you. Okay, frequency table for age, but this time not for our students, and it becomes worse and worse. Okay, don't see the subtitles. We have a frequency table for age, but this time not for our students, this time for our teachers. Okay, suppose that we have these values starting from, for example, 25 and goes to 65 or maybe 70, and we have count numbers, suppose that 105 and something like this, and also we will have these percentage numbers. %, and maybe 2%. Okay, we just have all these numbers starting from 75 and like this one, okay, up to 65, and it means we have a lot of numbers. And if we want to draw a chart like the previous example, like the bar chart, then we have a very messy chart, right? So we will have age in horizontal axis, and also this time I'm gonna use the relative frequencies rather than the absolute frequencies. Relative frequencies in vertical axis. Okay, but this time if we draw a bar for every value, a bar for 25, a bar for 26, a bar for 27, then it becomes very messy. So I'm going to define some margins for age. What does it mean? And I'm going to use this value for example, the age for 25, age between 25 and 35, and I'm going to use this point for 25, or let me correct this, 25 between 34 and 34, 35 and 44, and also between 45 and 54, and also between 55, and maybe we can say this 55 plus. Okay, and we just have these four margins and we call them as classes. These are classes, and this term stands for margins margins of values. And in a histogram we can have just 4 or 5 different classes. Okay, 4 and 5, not 6, not 7, not too much, but we can have 4 or 5 classes. And also I forgot to write the heading. This is an histogram. Okay, now we have these classes, and also we can have the frequency values. Suppose that we have a maximum of 50%, and this is for 25%, this is for 37.5, and also this is for 12.5. Okay, and suppose that we have the values, for example, we can have 25% of our teachers in between 25 and 34 years old, like this one, and we can have 30% of our teachers in this class, and it makes 55. And also we can have a bigger value like this one with 50%. And it will be wrong, sorry. Let me use 40%, for example. 40%, and it makes 40, 70, and 95. So we just have 5% for 55 plus. Okay, like this one. Okay, so this will be an histogram, and also we cannot use these margins, so we can use just no space between our bars, so it makes it clearer for you. And I'm gonna correct these bars by using no space. like this one. Okay, it's better. Yes, now it's an histogram. Okay. Now we can understand from this chart we have 25% of our teachers in the age between 25 and 34, and we have 30% of our teachers in the age between 35 and 44, and we have 40% of our teachers in between 45 and 54, 45 and 54, and also we have 5% in the area of 55 plus. Okay, this is a very important type of charts, and it's called histogram. And also we will study some modified versions of these histograms, but now I'm gonna show you a different technique. So I'm gonna clear the page for you, and this time we will have this data set. And now suppose that we have the heights of the students, and in this area we just have 100 numbers, and they are very hard to understand something from this data set, right? We cannot understand the average height or the maximum height or how many students do we have in some margin. We cannot understand, and we just use another technique to understand from the data tables like this one. And as a first step, we are going to put them in an ascending order like this one. We are going to put them in an ascending order, and I think we can call this data set with the term raw data. Okay, these are raw data, and as a first step we are going to put them in an ascending order. And it means it becomes larger and larger. We're going to start with the minimum value and up to maximum value, and then we are going to use a technique which is called stem and leaf plot. Stem and leaf plot. And in this technique we are going to use a stem part. I will draw a line here. I'm going to start with a line like this one. We are going to use a stem part, and then we are going to use a leaf part. Okay, for example, for this one we can have, for these two values, we just have a stem with 14, and we have leaves 7 and 9. Okay, 7 and 9. So let me make it clearer for you. For these data, for these numbers, for all these numbers, we have 15 as a stem, and we have leaves 2, 3, 7, 8, 9, and 9. Okay, 2, 3, 7, 8, 9, and 9. It's a method like to compress the data. Okay, to compress, and it becomes more meaningful when we finish this plot. Now, but there's an important thing. We just have to use the same space for all these digits. Okay, and I used 7 here, and also I used 2 here. I have to use the same width for all the digits, like a monospace font, monospace font. And for these numbers, starting from 160 up to 169, we are going to use 16 as a stem, and we have 4 of zeros, and I'm going to be very careful to use the same width for all digits. Then we have 2 of 2's, 3, 4, 5, 5, 5, 3, 4, 5, 5, 5, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2 sevens, 1 8, and 3 9s, like this one. Okay, now it's time for 17s. For 17s, we have these numbers. We're going to start with 3 of 1s, and it becomes harder when we want to write ones, right? Because it's a very narrow digit, it's a very narrow number, but we have to be careful. 1, and let me take this space, 1 and 1. Okay, we have to use the same width for all digits, and then we have 2, and then for 3 we have 3 of them, 1, 2, 3, and then 3 of 4s again, 4, and 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 2, 3, and also 1, 2, just 1, and 5 of, sorry, 6 of 9s, right? Yeah, 1, 2, 3, 4, 5, 6. Now we have 18s, starting from here up to here. 1, 2, 3, 1, 2, 3, and 1, 2, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 1, 2, 1, 2, 4, 5, 1, 2, 3, 4, 6, 1, 2, 4, 7. We have no 8, and we have 3 of 9. Okay, we have to be very careful to use all same widths for all digits, and for 19s we have 2 of zeros, 1, 2, 1, 2, 3 for 1, and 1 is the hardest one. So for 2, for 3 we have 3 ones, 3, 4, 5, and 6, and 7, and 9. And also we have 20s with a 1 and 4. Okay, we've finished, and now we have to add a key to show someone how can someone read these stem and leaf plots. Okay, I will finish with a key at the bottom part of this plot. Key is an example to show you how to read this table. Okay, for example, by using this one, 15 and 3 makes it 153. Okay, this is the stem part and this is the leaf part, so we can read stem times 10 plus leaf. Okay, also this is the stem and leaf plot, and also when we look at like this way, okay, when we look at like this way, it seems like an histogram when we look at in this way. Okay, this is the stem and leaf plot, and I'm gonna add some lines like this one, and now we just didn't lost any information. We still have all the data we have in our data matrix in a compressed table, and also we get a visual view like an histogram, right? So stem and leaf plot is a very useful way to present the data we have. Okay, like this one. When we look at in this way, we can see something like an histogram. Okay, so we have the margins between 140 and 150 and 150 and 160, and we have these bars when we look at in this way. Okay, it's a fun part of descriptive statistics, so it's a very useful way to present our data in a visual way without losing any information. Okay, so this is all for this part, and let me see you in the next video. Just take care of yourselves and stay at your home. See you later.